What is up, everyone? Welcome to the next lesson, and this is maybe going to be a little bit more theoretical than practical, because a couple things I want to say here is a very important aspect here. So we basically built our microservice stack and our services, right? The aggregator is basically the service of focus, right? Because if you want to do the complete microservice treatment for each of these services, we're going to stay here for a very, very long time. But we're going to take the aggregator as our victim to basically completely instrument and make this thing behave like a microservice should behave, right? And I want to talk a little bit about request tracing, because tracing in microservices is a very important aspect, and I will show you what tracing is and why it's important, right? So I'm going to open up this beautiful whiteboard here. Let me see if I can draw. Yes. First of all, don't mind my drawing skills. Hey, it is what it is, right? So basically, we're going to have our gateway here, right? Which is the gateway. This is basically maybe good for you to see this more of an architectural scheme. So we're going to call this gateway. I'm going to call this the gateway, or gate. Gateway is fine. I will take my time to write it down for you guys. Right, so that's that. That's the gateway. So basically what's going to happen is that we're going to have some kind of user. The gateway is facing user interactions, right? So it could come from a mobile. It could basically come from mobile or something, right? Mobile. But it can also come from... how do I draw a laptop? Something like this with some keys here. Look at that. Beautiful. Maybe a mouse, which actually is prohibited mouse, right? So this is basically the PC, right? And what's going to happen is that these are going to make requests to the gateway, right? Beautiful. So what the gateway is going to do, the gateway is basically going to handle for us authentication, right? Authentication, which basically can have an out service, right? Could be another service, but it doesn't really matter. That's what the gateway is going to do. The gateway is also going to basically route this request here from the mobile. It's going to route that to one of our services, right? For example, we need to have service A, right? Actually, to be honest, how can I... Look at that. That's beautiful. So the requests come into the gateway. The gateway is going to request that, for example, you want to fetch, like in our case, for example, the invoice, right? So it's going to service A. Service A maybe needs to call service B, right? Service B needs to call, for example, service C. And C is going to call service X. It doesn't really matter. Right. So what is the problem here? That if we do not have this concept of microservices here, right, then the problem is going to be, well, if we don't have the concept, the easiest part is going to be that the request that comes in here, the request, right, the rec will come into our application, right, and it will then basically return a response to the user, right? And if there is something wrong in our application, I'm not talking about microservices. This is actually nasty. I hope your ears are basically still okay. It's my Streamlabs login thing. It's so random. But hey, so if we don't have the concept of microservices, it's very simple, because there's only one request, right? User James is going to do a request with an API key or something, or with password, email, just something to authorize him, right? So to authenticate him, so we know who it is. And if there is a problem in our application, we know what request that is. It's the request from this mobile. It's the request from this authenticated user, James, in this case. But if we do a request based with microservices, what's going to happen is that there's a request coming into the gateway. The gateway is going to call service A, which is over the network, right? It's going to be JSON or gRPC, right? JSON, right? And this is going to call with gRPC, for example, gRPC. And maybe C is going to call this with the thrift protocol or something, or message pack, right? We're going to call pack. This is so nasty, to be honest, but hey, it is what it is. Message pack. If there is a problem here in this service, right? Let's say there is a fault, there is a bug. Something happened here, right? How the hell do we know where that request is coming from? Well, it's coming from B, but who is the authenticated user? We don't know. The gateway knows that, right? But we are going to be going deep into the microservice stack. They're calling each other, and in our case, what we are building is kind of okay. It's a couple services, but can you imagine you have something like Netflix where you have hundreds and hundreds of services? How are you gonna track that, right? Because we're gonna log a bug here, right? We're gonna log this bug. We're gonna log the bug or the problem. Actually, to be honest, it's going to be the error, right? Log the error. Hey guys, it is what it is. It's with my mouse, it's hard, right? As a non-mouse user. So we're going to log, for example, we're going to log a time, right? When does this happen, right? What's the error? The error itself, right? Maybe some kind of a request, right? It could be, for example, aggregate in our case, right? But what we also need is some kind of a request ID, actually, to be honest, or a trace ID, whatever you want to call that, a request ID. That's what we need here. Why do we need this request ID? Well, we need that because if the gateway, you can see that if the mobile makes a request, right, and we're going to make a random ID, for example, and that's going to be, let's say, 1, 2, A, I'm just making something, 1, 2, A, 4, X, D, right, something, 9 maybe, something like that. This is going to be the request ID. The gateway is going to make that. And the gateway is for each single message, right? The gateway is going to send that ID to all of these services. It's some kind of a, that's what they call tracing, right? It's some kind of a trace. It's the same as you go into the woods and you go in and you don't know where you're going, right? It's the woods, it's dark, it's a maze. And you're leaving these crumbs, these breadcrumbs behind. So if you want to find the way back, you can basically follow your breadcrumbs, right? If you know what I mean. And that's the same thing. If we have a problem in service C, we basically need to have the rec ID so we can find where, in all these other services, where this request has been, right? To see what's going on, to have a bigger, to see the bigger picture here. Because you can already see that with microservices, there's a lot of problems that arise, right? There's a lot of instrumentation needed. There is a lot of overhead needed to make these things actually work. When in a monolith, like our JSON API, it's very simple, right? We don't need to do anything. It's just we log something and it's simple. But in this case, it's much more nastier because we need to take all these minor things into consideration. That's request tracing. I hope that makes a little bit sense why we need that, right? So if we go back to our toll calculator here, the problem is that because we do not use a framework, right, and we do not have a simple set of transport, right, because in our aggregator, we're going to have make gRPC transport, we're going to have HTTP transport, so we don't have some kind of a predefined set of helper tools. We are just doing some stuff because we're making this custom, right? So most of the time, if you're building these microservices, you going to work with frameworks. And that's why a lot of these microservices are, back in the days, are being written in Java and all that stuff because they have these, I'm not quite sure, I think it's Spring or something, or they have these, Finagle Finagle, I think it's called in Scala. It's a specific framework for microservices, right? I think Twitter is using that, Finagle, right? And they have all these tooling and all these idioms which you need to follow, which makes it very easy to basically instrument all that stuff and make these tracing happen and all that shenanigans, right? And in Golang, we have also something that is called, let me show you. It's going to get called GoKit. Here, right? Let me bump the things up. So it's not something that we're going to implement here, because I think you need, for you guys, I think it's much more hands-on to write it yourself. So you're going to invest a little bit more time into bootstrapping these microservices, but you're going to much better understand these frameworks. And I think that's a little bit of the problem these days, that people are basically jumping to frameworks first and try to learn the framework, but completely forget the language behind it, right? They are just learning a framework and not a language. I think you first need to see what's need to be done manually for all this stuff before you're going to grab these frameworks. Because right now your knowledge is going to be much better and you're going to understand much better what's happening under the hood of these frameworks, right? GoKit is basically, you can see the examples here. For example, a string SVC. It's the same thing. It's actually how I teach this is the same thing that GoKit teaches or uses, because I was a contributor to GoKit very, very long time ago. Right? You're going to have the business logic, request and responses. They have the concept of endpoints. We have also the concept of transports, right? So they do kind of the same thing, but just a little bit more framework-ish, right? And yeah, check that out for sure. And maybe if you want, we can do a little, maybe we do a little tutorial about that. Maybe I'm doing a special lesson about GoKit, just to get you up to speed to make your service with GoKit, right? Maybe we can do that with another one, with another service we have, something like that. Let me know that. Right? So now we come to the problem here, like how do we implement request tracing? Well, that's another pair of problems, right? Because if we want to do that, right, we need to basically go back to the root, which is basically the data receiver. I think it's going to get called a receiver. How did we call that? Receiver main, like this, right? So what we are doing here is the receiver is basically the first endpoint in our microservice stack, right? So these services are calling each other. And what's going to happen, let me quickly turn off this stupid light here on the side. I'm not quite sure that's going to be a little bit better here. Boom, maybe just a little bit, right? So it's the first one that's going to get called. So he's responsible. Actually, the gateway is responsible. That's something that we didn't do, is basically the gateways for the user requests. That's true. This guy basically needs to make a request ID, right? So how could we do that? Is basically check in Kafka here, where is our data type, to be honest. Types OBU data here. So what we're going to do, we could make here a request ID. That could be an int. Normally it's going to be a UUID or something, but for the sake of, we can make this JSON. Let's call this request ID, something like that. If we can basically make this right, yep, that's perfectly fine. So that's going to be the UBU data. We're going to have a request ID because we need to put that on Kafka. And then what's going to happen is it's going to be the receiver, and then it's going to do, not quite sure what it's going to do. Is it the calculator? It's the calculator, yeah. The calculator is going to consume. Oh yeah, we're using HTTP client, that's fine. This is going to be the Kafka consumer start here. Let me open that up. Need message loop. Of course, guys, if you're wondering, as a good practice, you need to also implement something to close your loops, right? But I make this completely out of scope because we covered concurrency and all that stuff. We need to close these loops, basically, because it's just a clean practice, right? If you make something that is using a for loop, is running, for example, you could do something like a Kafka close or something, right? You could make something like this and call this close. It's just something on the fly that I'm doing here, and we could say c.is running, for example, is false. But you need to find a way to, yeah, something like that. Of course, it would be better if you can use a channel for that, but something like that. So you can close that, so you give the users or yourself or your colleagues the possibility to close something that's actually reading in another Go routine. Very important. Yeah, so we do this stuff. Let me see. We're gonna do this OBU data. That's fine. I think we're using the same data, so that's amazing. Right, so now you can already see if there is an error here, right? For example, there is an error at the read message. We have this OBU data here. That's fine. Okay, in this case, we cannot find the request ID. That's completely normal. But I'm talking about this. And what you also could do is do something like a distributed request ID, which is something that's not being taught that often, but sometimes what you could do is, because you need to, this basically is going to read this OBU data. And this OBU data has the request ID. The problem is that what if we cannot read this message and we want to log out here? We don't have the request ID. So then you can use something like a Redis, distributed Redis cluster, where you going to make new IDs and all that stuff, or some special application that makes new IDs. So there's always some request ID to be gathered. But that's that's nasty. That's a nasty rabbit hole we don't gonna jump into. So in this case, for example, log error f, what we could do is basically do a logres with fields here. You could say a logres with fields actually, to be honest. And that could be, for example, the error itself, which is going to be the R like this, and then we can say the request with fields is going to be like that, capitalized F. The request ID here is going to be, I think we can do data.requestID, right? So the only thing you need to do is make sure you basically log out your request ID everywhere, right? There are some options where there are some frameworks that actually help you with that, but basically where you can configure your logger with a request ID, so you don't need to specify it manually, but by the end of the day, this is how this works, right? So you need to do that everywhere, right? I'm not going to do this because it's just a minor thing, but I just want to show you how you could implement something like request ID, right? And that's basically by passing your request, by the gateway is going to make one, or basically in this case our receiver is going to make one, because actually what we need to do, I was just thinking about something very important. That's going to be the receiver here. Where do we make this new thing? OBU data. I think we make it somewhere. This is coming from the WebSocket is reading the same thing. What we could do here is, for example, each time we have this, right? Each time we're gonna read this bastard, we could say that the rec ID can be something like, in this case, I'm gonna do a super simple thing, rand. Is it int n or something? I think it's rand, by the way. It's gonna be rand int n, and let's make something like something very big, max int, something like that, right? So that's gonna be our request ID, and then we can say, for example, here we're gonna read this data.recID is going to be the request ID, something like that, or basically do it directly. That's maybe cleaner, something like that, right? Right. So in this case, it's going to be this, right? And then you can already see it coming in our receiver. We have that thing set up, I think. Is it a calculator, actually, to be honest, guys? A distance calculator. We're going to do this Kafka start here. Yeah. Message loop. And then we're going to send that thing, right? This calc service calculate distance based on the data, which is nice. This is going to make an aggregate request to the aggregators, right? So this needs to be changed, right? So we're going to have a value Unix OBU, and then we can say a request ID. If you do this over HTTP, you can also do it in the header. most of the time, well, sometimes you can see a request ID in the header instead of the data type. The problem is, and I'm not quite sure, because that's also a very valuable option. The problem is that if you use something like a transport, for example, gRPC, we don't have the concept of a header, right? So if you're working with JSON, request header is nice. If you work with gRPC, it's already a little bit difficult to do that, right? That's why I like it to basically just put the request ID in all your messages. And I'm thinking, has gRPC something we can that can work with that? Not quite sure. gRPC, let us quickly inspect this. How can we do that? It has a context, that's fine. Actually, let's search it up, right? gRPC request header. Is that actually possible? There are headers, but that's about gRPC HTTP2. Not quite sure it's gonna. I think it's specific to HTTP2. That's something you can investigate yourself. Basically, maybe gRPC has something you can put some header, some secret message, so you don't need to put your request ID in your messages, but by the end of the day, it doesn't really matter, right? It's just an integer or maybe a uint or something, or a UUID. It does not take up too many space in your messages, right? So you can see it coming. We have this already here, and now it's basically up to you if you want to log your request everywhere. I'm not going to do it because it's just typing in some stuff, but it's very important that I'm sharing here what request tracing is and how you can implement something in your stack. Request tracing, to recap, is just a way to basically put some breadcrumbs all over your microservice stack. So when there is something, when there is a problem, when there is, for example, a user created something in your application and he's asking to debug something, and yeah, you need to check where that request went everywhere in all the stack, you can use that request ID. Go to your Elasticsearch, you type in your request ID, and you're going to have all the logs specifically for that request ID all over your stack. That's basically tracing, right? I'll see you in the next one. Bye-bye.